Our first speaker will be talking about artificial intelligence and ethics, Natasa Manousopoulou, using AI in a responsible way and create positive impact for humans. A big round of applause, please, for Natasa.
So a man walks into a bar and approaches the bartender. The bartender is wiping the bar, as they usually do when they don't have customers to serve. And behind the bartender, among the bottles, there's a camera that fires up and some software that runs and consumes the input from the camera. So the camera scans the guy and sees that this is a guy around 35 years old, short-cut hair, wearing a suit and a tie. So feeds the data into an algorithm, and the algorithm makes the conclusion that this is a professional. Then the software that scans that image starts to make a little bit more of a complex computer vision on the man's image, so identifies the suit that the guy is wearing. It's an Italian suit, good quality, costs 4 digits or more, and he's wearing an expensive watch, and then feeds the data into another algorithm, and the algorithm says executive. Now, another algorithm kicks in, identifies that the person is looking a little bit distraught or disappointed or angry, and it's 3 p.m. And all this data is fed into another big algorithm that concludes that we have an executive sitting at a bar at 3 p.m. and they don't look very well. Now, the customer hails the bartender and orders a double scotch. And the algorithm says that there is a 15% probability that this person with these characteristics is going, after consuming the double scotch, is going to harm either himself or somebody else. And the bartender refuses to serve the customer and sends them out of the bar. Now, depending on how you feel about drinking and how you feel about business executives, you might see this as a good thing or a bad thing. Perhaps there's actually some bad thing that would happen that was mitigated by all this process. On the other hand, you might think, well, wait here. Drinking at 3 p.m. is totally legal. If I were in his place, I would be really pissed off because I have the right to drink whatever I like. I won't be driving afterwards. So there are many questions that start being asked when we face these situations where artificial intelligence algorithms start making decisions or supporting decisions about what people do and what they not do. Why should we do that? Does this create positive impact to society, or is it just a violation of this person's privacy and freedom to choose? There are many hows and whys that go behind all these scenarios, some of which you are already facing in your day job or you will be facing in your day job very soon. And it's not about the technology. What I described right now, apart from possibly identifying fake Rolexes, is probably very feasible with today's technology. So all these whys and all these hows are the key topics of ethics and artificial intelligence. So we're talking about very, very practical questions. Now, when we're talking about ethics, we usually are in the realm of lawyers, of philosophers, of people that study social sciences. My background is exclusively in computer engineering. I have no credentials in law or any other science like that. In speaking to you, I'm using the thoughts of people that sitting in company or academic boards have researched the topic, and a little bit of common sense, which is not as common as we might think, but I'm sure that there's a lot of common sense in this room at least. So, when we're trying to control or mutually decide on what people should or should not do, we're usually talking about things like laws and regulations. So, in our previous example, there is a law that says you shouldn't drink and drive above a certain threshold of alcohol in your blood. This is a law. Or it might be regulation. And what happens if you break the law? There are some consequences which are very well defined. You crash your car while being drunk, or you get caught while being drunk and driving, you're going to get some consequences. And we connect these with the government and with administration. And then we go into the more muddy, let's say, realm of ethics and morality, which are usually connected with the society, with philosophy, with culture, sometimes with more difficult topics like religion, and I've used the terms ethics and morality. Interestingly, they're very well connected. The one is a Greek term, the other one is a Latin term. So I would say that morality is about feeling bad about the things that you shouldn't have done because they're fun, and we're going to focus on ethics, which is about things that you should or you shouldn't do, we should or shouldn't do, because they are good or bad, respectively, for people, for society, or for around some basic principles that are important to us. So we're going to focus exclusively on the realm of ethics, which is about what we should or shouldn't do, regardless of what the law says, in order to create positive impact in society. And it's all about decisions. Ethics is all about decisions. So why is artificial intelligence and ethics two topics related with each other? Because artificial intelligence in software, more and more, is introduced in order to help people make decisions, or occasionally make decisions on behalf of people. So that's why this topic is important, and it's relevant to day jobs. If you're building an e-commerce application, you might have a little bit of artificial intelligence that will adapt the behavior of the application according to your user. Are you doing it in a way that's ethical? If you take these questions to your boss, they might be asking you, okay, that's all very well and good. I have to spend money, I have to spend time, we have to think, to create a board, to set down some rules on applying ethics when we're using artificial intelligence in our business. But all this investment that I'm going to make, is it going to give me back a return? The return can be financial, the return can be intangible, it can be social good, it doesn't have to be money. And it's a fair question to ask. At the end of the day, everything that we try to apply or every decision we try to make, we should be asking why. That's how progress happens. People asking why and then doing something different. But my advice to you is that if your boss asks you, do I need to invest in ethics? Does it have a return? And use these answers, not to have fun over beers, but to make solid business decisions, then get up and start running away as fast as you can and never look back. Now, if you read what's happening out there, if you go in any kind of publication that deals with artificial intelligence, you're going to see many questions being asked. And these questions some of them are far-fetching. They're going far towards the future. Some of them are closer to home. So many companies are developing autonomous vehicles. At some point in time, which might be not so far in the future, we may have trucks driving on highways which will be fully autonomous without a human driver in them. So what is going to happen with all these truckers? We're creating a gap there. We're taking some jobs away from people. Obviously, we're creating some jobs because the people that write the software for the autonomous car have come from somewhere. But I find it a little bit tough to take the trucker and turn them into a software developer or a data scientist. So we have to make an ethical decision about what we're going to do with these people. There is a very broad discussion that's happening, not very strong right now, but it's growing and growing, about having the minimum guaranteed income. Especially in societies that are well-developed, technologically developed, and assuming that not that far in the future, real estate is going to be driven by artificial intelligence. Medical imaging is going to be driven by artificial intelligence. The trucks are going to be driven by artificial intelligence. How are we going to guarantee that all these people are going to be able to survive? When the Industrial Revolution happened, actually people didn't survive. They all worked 16 hours a day in abhorrent conditions, and they died due to exposure to phosphorus or lead, or they just dropped dead because they didn't have the means. We don't want to do that again. As a society, we've progressed a bit. So there are lots of questions, the harder of which is, what should we basically fundamentally do to make sure that the AI that we built, the bot that we use to sell products to our customers on Messenger, is doing the right thing. Now, all the big technology questions have more or less been answered by the big science fiction writers. Frank Herbert says we don't need to create a computer. We shouldn't create a computer in the likeness of a human mind. Isaac Asimov, if you haven't recognized the guy, set down the 3 basic laws of robotics, which, how many people in here aren't familiar with them? You should go and read Asimov as soon as you can. It's good storytelling. Anyway, you can read the first one on what a robot isn't and is supposed to do. These 3 laws are supposed to be computationally ingrained into the positronic brain of every one of Asimov's robots in a very literal way, which makes for some good stories. And, you know, reading at it, I'm sure that by now you've all read it. I'm not going to read it for you. They look pretty straightforward and very, very reasonable. It makes perfect sense. Why don't we do that in our messenger bots? Well, things are not so simple and straightforward as they seem. So it says, injure a human being and a human being coming to harm. And then let's ask ourselves, what exactly do we mean by that? What is harm? If you've watched the movie Hannibal, there is this scene towards the end where Hannibal Lecter and Clarice Sterling, they're tied together by handcuffs on a fridge, I think, or something like that. So they're tied together, they're face to face, and FBI is approaching, and they're going to get Hannibal after a very long chase. And he has a hatchet, and he raises a hatchet. We close our eyes, and then in the next scene, we see Clarice Sterling with 2 hands intact. So we assume that he chopped off his own hand so that he can get away. So if we had a robot in this scene, seeing a person ready to either chop somebody's hand off or his own hand off, what would the robot do? What should the robot do? Because there is physical harm incurred, no question about that. Somebody's going to lose a limb. But for that person, the freedom that they're going to lose if they don't lose the limb is a much more important thing. Why should the robot make a decision on a person's behalf on what harm is personally to them? So once more, the story that Asimov said is good. It's good to think about. It's good to chat over beers, but it's never as simple as that. So there are other ethical problems that are very popular in artificial intelligence. The most well-known of them is called the trolley problem. It's not necessarily happening in Lisbon, like this picture, but the general idea is the following. We have this trolley, this small train going down a rail, and the rail can go either to the left or to the right. So the train is going to go towards the right, and there is a person tied. Sorry, there are 5 people tied on the tracks. So the trolley is going to hit them and kill them. And then on the other side, there's one single person tied on the tracks. And you have a lever at the bifurcation, and you can pull the lever, and the train, instead of going to the right and killing the 5 people, it's going to go to the left and kill the 1 person. So do you pull the lever or don't you pull the lever? Is the life of 5 people more worth than the life of 1 person? What if that 1 person is a child? What if the person is the president of a country that you like? What if that person is a pregnant woman? What if these 5 people are criminals? I'm not asking you to answer this question. I'm just saying that if there are questions so complicated that we humans have an issue answering them confidently, how can we expect to codify this kind of decision-making in algorithms and have them decide on our behalf? It's not easy. So what can we do to actually help ourselves to improve the situation? There are many companies out there, big technology companies, that are building artificial intelligence. And rest assured that all these companies, whether it's obvious publicly or not, are thinking about these topics. And yet, these companies have made fundamentally big and very public mistakes. I'm going to start with something that the company that I work for did. So Microsoft created a bot that they called Tay, and they released it on Twitter. It was supposed to be a childlike bot, a bot that learns. You talk to it, you teach it stuff, it learns, it becomes better. Within 24 hours, this bot had become the worst racist brat you've ever encountered, and it was shut down very, very promptly, never to return again. It was a big public embarrassment for Microsoft, but it was a very, very valuable lesson. So that was incident number 1. Incident number 2 is about Facebook, and it's about the Cambridge Analytica scandal. Now, there isn't any artificial intelligence clearly involved in this case. What is the vast use of user data to feed into AI algorithms in a way where their privacy was violated. So it wasn't the AI itself, it's how the AI was supposed to be created that wasn't according to ethical standards. Another big scandal for Facebook this time, and the third one is more recent. In the recent Google I/O conference, perhaps you've all seen this part of Sundar Pichai's keynote, where an AI is supposed to be calling a hairdressing salon to make an appointment on behalf of a customer. And it sounds very, very human-like. You couldn't tell that it's synthesized voice. Some people doubted that, but let's assume that it is. And then, after everybody got over the shock and stopped being so much impressed, they asked themselves, this AI misled the person on the other side of the phone line thinking that they were speaking with a real human. Is this an ethical thing to do? Is this a transparent thing to do? And, well, there is still a dialogue happening. So there are many, many possible issues that will arise, even if people have the best intentions, because I'm sure that for a person that has a speech impairment, having a bot making an appointment on their behalf is a lifesaver. So it can be a very, very good thing, but we have to understand how we deploy it and how we communicate it. So there are several principles that we can apply to improve the situation, not to solve the problem. This is not a problem that we're going to solve fully anytime soon, but to improve the situation. And some basic principles that we can apply to help ourselves be convinced that the AI that we built and the AI that we deploy towards our users has some basic fundamentals that are considered ethical. The framework and the words that you see here are coming out of Microsoft's internal framework for ethics in artificial intelligence. There is a board called Aether, which actively thinks about these topics because Microsoft is betting a lot on artificial intelligence as a business, but also on behalf of the society. We actively try to think how we should be building this AI and how we should guide our customers to build this AI. So these are the basic ideas that I want to share with you. And the first set of principles is about fairness and inclusiveness. So how can an algorithm be unfair? Here we have an example of face recognition algorithm, something that you would use to, I don't know, unlock your phone or be recognized at a bank or some other touch point with a digital business. So the algorithm that got this bad rap in the New York Times could be very, very successful with just 1% error if they were recognizing men who are white. One could make the assumption that this is a subset of people very similar to the software developers that actually created. But then if we went to different gender and ethnicities, things got a little bit more complicated and worse, to the point when we had non-white females, the error rate was 35%. If you get an algorithm with a 35% error rate, it's an algorithm that goes straight to the garbage bin. It's totally useless. So something that's actually built very successfully for a subset of its potential users, in others fails miserably. Why does it do so? Did the developers wanted to exclude black women? Certainly not. I'm sure that they had the best intentions. The problem is in the data that we use to train this kind of algorithms. If they used a data set of pictures to train this algorithm that was 90% white man and the rest in the other 10%, how could this algorithm actually perform? There are other examples that fairness happens or doesn't happen. One very good example comes out of a marketing campaign that a coffee company did at an airport. You go near the coffee machine, if you yawn, then you get served the coffee. If this algorithm isn't fair. So I don't know, I have long hair, and if I yawn, it doesn't recognize me correctly, it doesn't serve me coffee. It's not a big deal. It's a marketing campaign gone bad. But what happens if we have an algorithm that unfairly excludes asthma patients from being admitted into a hospital because their risk of pneumonia complications is considered to be low, which is actually an example in the real world, in experimental stage, fortunately. These people are going to probably die out of complications and pneumonia. It's no laughing game. It's a very important thing. So what can we do to become more fair? Actually, the devil's in the data. If you want to create a fair algorithm, you need to have a fair data set. And in order to have a fair data set, you have explicitly to look at your data and ask yourself questions about who you're including and who you're excluding. And having people in your team or people that are going to review this data and understand if they're biased or not is going to be a good thing. Now you'll tell me, I have a small team, we're 5 people. How are we going to actually have this diverse team with all the combinations of genders and ethnicities and languages and cultures involved? The answer is that you have users, you have A/B testing, you have focus groups, you have pilots, you have beta testing. You can do it recursively with the help of your users. Then we're moving into maybe a little bit more intangible things. We're talking about transparency and accountability. Transparency essentially is an algorithm, a machine learning algorithm, an AI algorithm, being able to explain why it decided what it decided. Why did the algorithm decide that the asthma patient had a low risk of complications, or vice versa? And accountability is about who is responsible for the outcome of that action. If you go to a doctor and the doctor said, nah, you're okay, go away, go home, take some aspirin, and then you die, the doctor is accountable. If you go to a hospital and a decision support system helps a nurse triage you and tell you, go away, and then you die, who's responsible for the decision that was supported by this algorithm? These are interesting questions and something that you need to start thinking about yourselves, because if you're building an e-commerce app, and this e-commerce app includes some kind of artificial intelligence within it, it's not a life and death situation, but definitely you should start thinking why and how this app is going to make decisions and adapt its behavior towards users, because it might choose and recommend a product so that some users might find offensive. Some people are very, very quick to take offense these days. So accountability is all about having a framework for response. I won't go into the detail because usually the accountability questions are going to be handled by legal departments. But the general idea is understanding what the impact of our technology can be and how are we going to respond if something goes bad, especially publicly, especially with regards to communication. So what will happen if the decision support system that we're building in the hospital tells a nurse to send a patient away and something happens to the patient? To be very ready to respond to that and to react to that and to assign accountability for that. Now, transparency is about explaining decisions. Why did you make the decision? Today, there were some outcomes issued from a recent, was it a Tesla or an Uber crash, that explained why the car crashed. It took some time, it took an investigation. The car had crashed nevertheless. What was there in the software and in the algorithms to help the investigators decide how the decision was made? There are several types of algorithms in the artificial intelligence, and some of them are more explainable than others. When you have a decision tree, things are pretty straightforward. You can, if there was a decision tree in that car, we could even walk a judge down that decision tree and tell them, this is why the car didn't brake. If instead of a decision tree we were using some machine learning algorithms like clustering or regression, then maybe we could plot our data and show to the judge, you know, the car didn't brake because the data point was here and it was in this situation, the car wasn't supposed to brake because there are good reasons for that, or because it was this cluster. So we're still in the realm of being explainable. But what happens if we have a neural network? That's a very nice picture of a neural network. We can visualize it, right? What decision is it going to make? Go figure. We can't explain a neural network. Depending on the algorithm that you're going to use, your AI is going to be more or less explainable. Deep learning, things are very, very tough. Decision trees, things are somewhat better. So the general guideline here is if you can use a simpler but explainable algorithm that produces similar results to a more complex and non-explainable algorithm, go for the simpler one. Perhaps 0.2% in accuracy is going to be unimportant if you're able to stand in front of the judge and explain to them why your AI made the decision that made the person go to prison, that made the person be denied a loan or crash the car. Then we're going into safety. We're again into that car crashing space. Did you know that the first Tesla that crashed was actually in Greece, near Florida? Well, I don't know how anybody could drive in the streets of this country and engage autopilot. They must have been really, really crazy. But the thing is that these things take a lot of publicity. And you know, sometimes, even though there are the best intentions on the behalf of the people that are building this AI, people mess it up as well. This happened, I don't know, 2 or 3 days ago. There was this police car parked. Somebody very unluckily crashed into it, and then the driver said, oh, it was autopilot that messed up. Actually, if you read the Tesla manual, this was a very typical situation where the autopilot was nothing to blame because the driver had to be engaged during that situation all the time. So what does that tell us? It tells us that when we're building AI, first of all, we have to think very, very actively about our users' safety. And second, we can never assume that the people are going to take accountability for their own stupid mistakes. We have to build something that's as safe as we can, and we have to very clearly show to the users and show in every possible way what the other cases are when we can't take care of their safety anymore because it's not technically feasible. And the Google research team, the team that's in Google Brain, has identified a very nice framework that we can use when we're thinking about safety. So if I'll go very quickly through it. If we have an AI-based vacuum cleaner, there are several of these in the market already. How can we make sure that this vacuum cleaner is going to learn our house, the layout of our house, so that it can clean it without creating a mess and without breaking something at the exploration change? What happens, how does it react when we remove a couch and we put something else in its place, or vice versa? So how does it react to new situations in the environment? Is it going to start banging on the new couch again and again and again until its battery runs out, or is it going to learn to go around it? How are we going to make sure that it's not going to run over the baby or the dog, or it's not going to fall off the stairs? How do we incorporate all these safety precautions in our learning algorithms? What can we do to make the vacuum cleaner avoid going through the entire house? Because, you know, it's easier this way. The algorithms are going to be rewarding, and at the end, it won't clean the house at all. And how can we make sure that we test these in a safe environment where a human being can actually confirm that this is good and this is not good before we release our vacuum cleaner to the public? You might not be building robotic vacuum cleaners today, but every time that you're starting to use something more complicated and one of the available AI services in your application, you should be thinking of all these things. And then we go into privacy and security. Oh my God, this is getting more and more murkier. So privacy. Who hasn't felt sick and tired of hearing the 4 letters that start with G, which I'm not going to repeat. So privacy is a big thing. It's a big thing in the regulation space. It's a big thing in a real life space. If we want to respect privacy in our AI application, something that's very easy not to do because AI is based on big heaps of data. We want to collect the data and we want to use the data, but we have to respect the user's privacy as well. What can we do there? First of all, we have to understand and respect the spirit and not just the letter of the law. If you're collecting information about our users' personal habits in our web application, having this pop-up that says, I do, well, it's not enough. It's nearly not enough. We have to make sure that we're not capturing information that might be useful to us, but at the end of the day is a violation of the user's privacy. And that's an ethical thing, because maybe our lawyers have got it covered. And we can use their technology-based methods that can support us. Microsoft Research has developed two of them, differential privacy and homomorphic encryption. The second one, which is really interesting, is essentially an encryption method that allows us to run machine learning algorithms on encrypted data without actually decrypting them, and then using the encrypted data that are the input to feed the algorithm and use the output. So we have this big block of encrypted data, we process it, we never understand what's in it, we never violate our users' privacy, but we still have a performing machine learning algorithm. And then we're going into security. Instead of talking about security, I'm going to show you something about fakes. So this is a video produced by NVIDIA researchers. And you're going to see the outcome of an AI technology that's called generative adversarial networks. And I should be clicking on this play button and not the one on my screen. So what you're going to see here is neural networks that compete against each other, the one producing fake images, the other trying to understand if the images are fake, with the ultimate goal of creating very convincing fake images. None of these people that you see here in this video are real people. They're all created by neural networks, and they look so, so amazingly real. So can you think of how many ways can you think that this can be used for good? Artificial actors, amazing. Artificial models, I don't know. How many ways can you think of things going real, real bad? Have you heard the term celebrity fake porn recently? I'd encourage you to go to YouTube and watch that video. It just shows how these neural networks build these fake images and how these neural networks can be used to actually fool any kind of AI algorithm that tries to do security. For example, if you have a face recognition program, you can build a generative adversarial network that actually fools that program. Every time that we have a machine learning algorithm that identifies a security threat, we're going to have some other machine learning algorithm that tries to defeat that guardian. So generative adversarial networks devised in 2014 by a guy called Ian Goodfellow in Montreal, who now works for Google. And I was reading an article today in MIT Technology Review that said, well, I'm scared of what I created. And we have to be very, very prescriptive in how we use these algorithms for these kind of scenarios, or maybe some more complicated. I got 3 more minutes gracefully. Thank you. So I think that I'm going to stop here and let this video play for another 3 minutes while I take your questions. Yes? We're having a mic coming to you.
Hi. So there's a discussion about targeted content.
Can you speak up?
There's a discussion about targeted content, which is you have an artificial intelligence program learning your habits. Whenever you make a search on Google, for example, it returns back based on your habits. specific content to your habits. So there's a discussion about if this actually is good or bad, because essentially it removes the freedom from yourself to just choose the news you want to see. What's your opinion about that?
You'll see that I'm thinking. And I'm thinking because if there is a dialogue about it, it's probably a very hard question to have a black or white opinion. I'd say that transparency is what counts in that respect. So there are two ways to actually apply this algorithm. The one is I wake up in the morning, I fire up my favorite app, which is, I don't know, serving me news or any other kind of information. And this algorithm, which knows me and knows my habits, is going to serve me what it feels is best for me. This will create probably in my mind a monoculture. It's like, you know, Facebook showing you posts from people that you probably agree with. I'm not very happy with the situation because debate and being exposed to different thoughts and different opinions is what grows humans. But if there is some transparency in there, and on top of being served this stream of optimized content, I have the ability to switch it into something that's not optimized for me. It might be optimized for somebody else, or it's less filtered, or it's totally unfiltered. And I have the option to go back and forth between the two, or to understand why it's showing me this. Then I have the ability, I'm given the opportunity to either change my behavior and alter the algorithm, or at least to say, I don't want this personalized content. And I'm going to go with the one that's unfiltered, because I find out new things. So I think that transparency is a principle that helps in these situations. So are many people going to choose that? Maybe not, because it's easier to follow the path of least resistance and being served what you like, what you prefer, and what you agree with. But at least the ones that want to see it differently are going to be given an option.
Another two questions.
In which case, okay, go ahead.
Hi. So I understand the topic of the talk in general is about AI and ethics. But considering the recent four-letter policy that you just mentioned, we're having some discussions on our team, and it's, you know, a team of 5 people, and we don't have like a big megacorp committee of ethics that can kind of resolve these ethical questions. Is there anything you would recommend for the, let's say, budget ethical decisions that can get really complicated, you know, trolley problem and whatnot, but oftentimes they don't reach that level of complexity, but still are kind of beyond the scope of like my expertise in knowing how to write code. You know, who do I go to? How do we move forward in those complicated questions?
So to rephrase your question a bit is, how do we make privacy and ethical decisions when we're having a very small team and effectively no outside consultancy to help us make these decisions? I'd assume that you're 5 people with a good conscience and good principles, and you can be your own ethics board, you know. You can have your own ethics charter and put down 10 sentences and 10 controls that you can do and apply in your everyday work to not to implement a specific regulation, because that's a little bit more, let's say, organized, but to make sure that in the end you're doing the right thing. So when you're doing your telemetry, you're building an application, you're doing telemetry. In your telemetry, you're capturing some data. You can have a principle that says that there's this kind of data that actually would be considered very private for the user, and we won't capture them, or we will anonymize them, or we will encrypt them in a way that it's not identifiable. And there is this data which is generic, it's about our application, and we're going to capture as many of them as we can for the good of our application. So we're talking about concrete technology decisions that you're going to make, which are going to be guided by your own sense of good. That's one thing. The other thing is that if you go to the Partnership for AI website or the World Economic Forum website, if you look at what's being published out there, you're going to find many guidelines that you can actually follow and not start from scratch. So the framework that is shown is coming out of Microsoft's approach. I'm not sure if we've published that. Yes, we published that externally. We have this great ebook that's called The Future Computed, which is about AI and the future of humanity. And you can look at and read, and it's, I don't know, a few pages. It's 40 pages, something like that, that explains some of these principles. So since ethics is something that's not prescribed by law, but they're very tied to how we feel, what makes us feel good in the end. If we don't have some board to tell us how to do it, we have the opportunity to tell ourselves how to do it without spending infinite amount of time. I'm not sure if this is a satisfactory answer to you, but it's a little bit akin of the question, how do I raise my child if I don't have a governess? You know, it's, you can do it yourself.
And one more question, guys.
Hi. When you said about accountability, basically, let's suppose in this case the doctor had a bad day and told the person go away. What will the AI had to tell you that? I mean,
what's the equivalent of a bad day for artificial intelligence?
Or what is the reason to tell you, to lie to you, or to give you a wrong
to make a bad
information?
decision.
Yeah.
So I'll go back to that example, which I didn't explain fully because I hope that illustrates. So what happened is that people were building an AI that would help doctors triage pneumonia patients, outpatients at the hospital. So you have some symptoms that are pneumonia symptoms. You go as an outpatient, so you wait for your turn. There is no rush there. And then somebody triages you and either tells you take this medication and go home and you'll be fine, or they admit you into the hospital because the pneumonia might have complications. So as people were building this decision support system, a data scientist, as they were doing the testing on their data, they observed that when the patient had asthma, the algorithm consistently said this is a low-risk patient. Now, data scientists are a doctor, but I think it's a little bit common sense to say asthma, low risk. This doesn't sound very good. So they asked physicians, they asked the doctors, and the doctor said, well, stop it. This is a big problem. Actually, the algorithm is going to make a bad decision there, and it's going to make these people potentially die. So what was happening is the following. When somebody has asthma and they start having pneumonia, their symptoms are very severe. And they don't go as outpatients in the hospital. They go to the emergency room directly. So the algorithm was fed data only from the outpatient clinic and not the emergency room, and didn't take into consideration the patients with asthma, so it made an incorrect decision. So the AI is not going to lie to you intentionally, but if we build it with data that isn't representative of the decisions that it has to make in the end, then it's not going to perform correctly. That's why the physicians would have to test it. That's why it's good that the data scientists were blindly doing the data processing, but they were asking themselves questions. And it would be good if somebody was doing the oversight there and said, we need data that's inclusive. Outpatients, rural areas, multiple hospitals, the ER, so that we have a representative data set. So it's not the AI, it's the data that we feed and we use to build it.
Thank you so much.
Thank you for that.